Hello everyone, it's me, the Kudukadian man. Yep, no longer called the Kudukadian, real life Kudukadian, now calling it Kudukadian Vision for my channel, because this is a vision. Now, have you ever heard of the oh my gosh, I'm about to start off wrong. No. Have y'all ever heard of the space elevator concept? It's a common concept. If you haven't heard about it, here's what it is. It's basically just building the elevator that goes up into space, and we can basically lift any type of spacecraft up into space, saving us lots of money on fuel and all that. Now the problem is, we don't really have a lot of resources for that. Said that very weird. Resources. We don't have a lot of resources for that. On top of that, the difference in the gravitational pressure, or well, not even gravitational pressure, atmospheric pressure. The difference in atmospheric pressure is gonna it makes it weaker. So like as you go farther up, like the atmospheric pressure gets a little bit weaker. So by that happening, and there's an actual phenomenon where I don't know if you ever heard of, like two satellites that crashing together and then they shatter into pieces, causing like the exospheric pollution of basically satellite shards just floating around there. Well, yeah, same thing could happen to the space elevator itself. Just something could crash into it, shatter it to pieces very easily, and then someone be floating, and then on top of that, the vibrations might cause it to tip over, because you gotta think it's going to be very skinny compared to, so it's already going to have troubles with probably tilting a little bit. We're already going to have trouble with the stabilization process. Well, it's going to probably wiggle and tilt just a slight bit. There's no really way to control all that vibration activity, and then so likely going to tip over if it gets hit, or it might tip over eventually anyway. We'll have to predict that. A lot of predictions there. But here's the thing. Instead of doing that, we could do a stratospheric elevator. That's what I was about to say earlier, but I was too ahead of myself. We could do a stratospheric elevator, one that particularly reaches the stratospheric median at 31 kilometers. How we do this? Well, here's an actual physical example that exists out there. This is it's not the stratospheric elevator, but there's a little small scale thing that actually exists now. It's called an 8-point jack lift. Well, at least that's what I looked up online. That's what popped up, but not sure exactly what it's called. But here's the clip. So, as you can see, that is the concept we'll be going based off. Basically, rods being turned by motors, even though it's not going to be a single rod in a motor when we actually build the physical design. The physical design, the rods will actually be towers made of ASTM A514 steel. It's a steel alloy that we can use, and we precisely need it to be 26.5 kilometers tall. Now, how would that reach this stratospheric median? How would that reach the stratospheric median at 31 kilometers? Well, it's all about the building location. I already got the location in mind. We'll save that for another video on what we got to tackle to even build in that location first. Now, as for that, we want to build it specifically. We want 4 of these towers. The rods, actually, that you saw in the clip will be these towers. The towers will be the rods. And the platform, which will be made of a Ti64 titanium alloy, which is better at dampening, the vibrations of the rocket itself. Now, as you can see inside some of these pictures that I'm putting on the sides of the video, you can possibly see that I've already been planning this out and written down notes. So these notes are in particular are going to show you what I mean, what I'm talking about, what I've written down and calculated so far. Obviously, like I said, it'll be a titanium alloy. It's better at dampening. And if you see, like, I didn't write it in the notes, but I was using a Falcon 9 as an example with assistance from AI. I understand how y'all feel about AI, but hey, AI helped me develop this idea faster. That's all I can say. If I would have did it on my own, been a lot of calculations and just trying to keep up with the numbers, keep track on what I'm on. But the AI was able to do that a little bit quicker, a little bit more simpler. So, other than that, back to the structure itself. So the structure itself, okay, so like I said, the 4 towers going to be made of ASTM A514 steel alloy. The platform itself, which should weigh 1,000 tons, it has to weigh 1,000 tons to be able to support the pushing force of the rocket when the thrusters come on and thrust the rocket up. And it's only going to last about 10 seconds, particularly like like I said, going based off the data from Falcon 9, basically 9 point something GREMs. I didn't put that in my notes, but like that's basically the type of vibration this platform will need to be able to handle, as well as the towers and also the locking mechanisms for the towers. Speaking of which, getting ahead of myself again, towers will be going straight through the platform, as you see in the clip, as you saw in the clip video. The platform will have like tapped holes. I would say probably particularly made of steel themselves, like a little hole, tapped hole that you put inside the hole, that you shove inside the hole of the titanium platform. Probably gonna add more weight. Probably be a little bit less weight because steel, it'll be made of steel as well. That way the steel can rub against steel, or you can make it work or rub it or rotate within the titanium itself, making a little threaded tapped hole. So, like I said, the towers will run through the platform. Obviously, it'll raise to a certain height. Probably won't be exactly 31 kilometers, but close. If we can get close to that, that's better. You know what I'm saying? And then launch the rocket from there. Now, at the base of these, towers, you want to have upper and lower teeth. Okay, each of these towers, which will be 4 in total, will have upper and lower teeth. Now, keep in mind, each tower is going to be approximately 850 tons because they need to handle the forces of the wind as well as the weight of this platform. They're going to be about, I'm going to say, 30 centimeters thick in diameter. So, like I said, they're 30 centimeters thick in diameter. So, which is not really that bit thick when you think about it, but hey, we'll see. In real life, I didn't do a whole circle thing yet, so that's yet to be determined. Anyway, so then we got to hit with the base, upper and lower teeth. For the upper will be for the locking mechanism, the lower will be for the motors that spin the towers. Okay, now we're gonna bring it down to 1, but I'll tell you how much each will have. So the locking mechanism is gonna be approximately made of 6 locking. Get my numbers wrong. 16 locking pins connected to a double sliding cylinder, which is connected to a die spring. Probably they can handle about 10 pounds. Well, die springs can handle about way more. And connected to electromagnetic motors. Particularly an example out there for the electromagnetic motors would be like the Thomson Electric 10. That would be the example type of motor we'll need. It'll have to be have to have a worm ring. So that way, all it really does is just pull the pins off of the upper teeth and pull the spring back. Pull the spring, which retracts the locking pins, and then lock in place. So that way you're not using too much electricity there. They'll probably use about 23 to 36 watts of electricity. Then and that's the type of motor system you want as well. That'll be the design for the locking mechanisms. There'll be 16 of these on each tower. Then shifting down to the lower teeth, we're gonna have like DC motors, DC electromagnetic motors that are. There's gonna be 2 per tower. They're gonna consume about, well, 2 on each tower. The 2 together will consume 7 megawatts of power. And then obviously, like, something about 4. We ended up with 30 something. My math is not mathing right now. Brain messed up right now. But yeah, so they're gonna be using up about 7 megawatts of power or so, and that was actually, yeah, because both each one uses about 3.5 megawatts of power. And they're gonna have like a planetary gear system, which will allow for like the rotation, like the rotating effect to rotate the tower and spin the teeth a certain way together, because you need the teeth spinning a particular way. So that'll be that kind of thing right there. So the teeth will have to spin in whatever direction, counterclockwise, clockwise, whatever direction, we'll design it to go up and down. So obviously, alternating current to change it. Yeah, like I said, they're DC motors, electromagnetic motors, which electric 10s are also type of DC motors, but they're not the ones that we'll be using for the spinning feature, because the spinning ones have to be able to spin that 850-ton tower together. So those will be the 2 at the bottom for the spinning motion. I was thinking about probably like having like a hollow inside of the tower, hollow base inside of the tower, so that way it just sits on top of something. Have like bearings that can allow it to smoothly rotate a little bit more instead of just putting all the pressure on the motors themselves. Work out the kinks. Well, having full work out the kinks on that, but that was an idea in mind for that, just to give it a little bit more fluid motion when you spin it. That way, just to hold it all in due time. So now, then you want it. So this is how we'll be able to physically spin this platform. Spin these towers, which will lift this platform up. Yeah, like I said, the planetary gear system is the best design to have these motors work together and spin it. So it'll be like a planetary system. So maybe slightly different, as I'm thinking more like 1 gear at the top and 1 gear above the sun gear and 2 gears below the sun gear. So that way, when the sun gear spins, it spins the top in one direction, but also spins the bottom one, the one below, directly below it, in one direction to spin the other one in the same direction as the top one. So it's going to be like a planetary gear system, but probably designed a little bit way more different than how a typical planetary gear system is designed. So will be, I'll say, 10 wind turbines, the large ones that produce about 5 megawatts of power each is how much we would need to be able to power these DC motors, along with the electric 10 style motors for the locking mechanisms and for the spinning rotation. That'll be enough power. So it'll be like we'll be working with about 50 megawatts of power. The 2 motors at the bottom are going to be using about 40 megawatts the motors at the bottoms of the towers are going to be using a total of 40 megawatts. That's by themselves. So, and then the locking mechanisms will be using about 23 to 36 watts of power, which is way less than megawatts. So yeah, the 50 megawatts would suffice. Now, we're not only going to have 10 turbines, but I'll tell you why we need more turbines in another video. just focus on the physical design itself. So, like I said, we got those motors. Now we got to think about how it's going to sit, because where it'll be located at, which I'll talk in another video. As I said already, we want a concrete slab. Reason why you want a concrete slab is because you want this to be leveled. You don't want difference in elevation, because then you got to change the different size. You got to change up the sizes of how you do the towers. And you don't want to have to change the sizes of how you do the towers to just to accommodate for that. You want the towers to be the same length as each other. So you want them on a leveled platform, and with the ground having natural difference in elevation, you're gonna have to use a stone slab to create a leveled elevation platform, like flat base for these towers. It'll be about 5 acres. 5 point something acres. But I'll say just make it 6 acres altogether. The stone slab would be about 6 acres itself. And be about 7 meters thick. So, about 7 meters thick, depending. Like I said, difference in elevations. One end may be longer than the other, just to get that level plane. You want it to be at least 7 meters thick, though, and it has to be a concrete mixed with steel fibers to accommodate for extra vibrations that may be experienced. And then also you want to have it mounted in the ground with 3 meters long rods. It's mounted you want to use steel rods that can mount 3 meters into the ground, just to really hold that in place. And that plays a part in where we'll likely build something like this. I'm in the USA. I know a place where in the USA we can likely try to build something like this. So now, I think that mostly covers how we will design it. Like I said, the DC motors. There's like with the electric 10 type motors, which are I think also are DC motors themselves. The 10 wind turbines, the large ones, 5 megawatts of power. On each. And then, like I said, the 4 towers, which are basically the rods in this case, going straight through the titanium platform, TI-64. Like I said, the tower is made of ASTM 8514, sprayed it and coated with an aluminum coating to counter rust, or to prevent rust for as long as possible. And then, like I said, have it stop, do the rotation. Planetary style gear system for the motors that spin the physical tower. Tower's going to be about 850 tons. Platform is going to be about 1,000 tons. Lifting, like for an example, a Falcon 9 rocket, probably be about 1,550 tons. Accounting for the downward force as well. Which the platform should also be able to handle. Also could have comment that, but this is more of a plausible idea versus building a space elevator. We could just build a stratospheric elevator just to have like just a way to easier ways to get aircrafts into space. Not have to use a bunch of fuel. Not have to do a lot of G-force resistance. Obviously, still want to deal with G-force resistance, but it wouldn't last as long as shooting straight from surface ground. And basically, there you have it. That's it. Stay tuned for those other videos where I actually talk about the location and also what else we would need to manage such a structure.